Okay, so section lesson 2.05 is on complex numbers, which we're already talking about, correct? We were talking about complex numbers, which are sometimes called imaginary numbers. We were talking about that idea of I, correct? So this kind of does go along with that, and it continues on with that idea of I. And let's remember what I was on whatever last day we met was Tuesday. Oh, I think it was Monday. Actually, we learned this, and then Tuesday we went over it again. We actually learned that I, oopsie, right, let me write that a little more neatly. I is the square root of -1. I always do a cursive I. If you want to do just a regular I, that's fine too. I just always write, I don't know why, I just always write a cursive I for these. We also learned that I squared is -1. And that one we used a lot more on Monday and Tuesday, correct? We were always seeing these I squareds and we're turning them into -1s, okay? Today we're actually going to use the fact that I equals the square root of -1 a little bit more. We're going to be using that idea. And we're going to be using that to simplify radicals. So we're going to simplify all these radicals right here. I think you guys have done this before, probably in Algebra 1 and also in geometry as well. But you've done it with positive numbers, okay? So you may have broken, you know how you break it down with that little factor tree and you find you find twins is how I do it. So I'll explain that if you kind of don't remember. So this is actually very similar to that, except we have a negative inside, okay? And all that really changes is our first step. So anytime we're breaking down these radicals and we have a negative inside, I just want you for your first step to put an I in front of this and then change that negative into a positive. So that's our first step always on these when we have a negative inside, okay? So now we just look at that as the square root of 36. Now, I'm thinking that some of you may actually just know because 36 is actually a perfect square. So what's the square root of 36? 6. And so this would be I times a regular 6 now. It's not rad 6. It's like, because I took the square root, correct? And so that's just I times 6, which normally we're going to write that as 6I. Kind of like if we had x times 6, we would write that as 6x, correct? Okay, so my answer for this is 6I. So what we're saying here is that the square root of 36 is 6, correct? So the square root of -36 now I'm saying is 6I. So is that different than doing the square root of 36? Honestly, no, correct? The only thing that's different is I, okay? Not I like me, but I, the letter. Okay, so let's take a look at number 2 then, okay? Number 2 is a little bit different, so stick with me here. Our first step is still going to be the same, which is going to be, since we have a negative inside, we'll put an I in front of the radical, and then we'll change the -80 into a +80. All right, now, is 80 a perfect square? No, it's not, okay? So we cannot just take the square root of it. So instead what we do is we break it down, okay? And so I'm going to do a little factor tree. I'm going to go off to the right here. I know a lot of times we do this going down. That's okay if you want to do it down, or you can do it off to the right. It doesn't really matter. And so now I just got to think of two numbers that 80 breaks down into. So what two numbers multiply to make 80? 10 and 8 would work. 4 and 20 would work. 2 and 40 would work. Like, it doesn't really matter how you break it down. We're going to end up at the same spot anyway, okay? Then what we need to do is just continue to break these numbers down until we get to all prime numbers. Prime numbers are numbers that don't break down anymore, okay? So, can I break down 10 further? Yes, that'll be 2 and 5. Oh, can't write my 5. Man. Not working well. There we go. All right. Can we break down 8? Yes, I would say that that's 4 and 2. Can we break down the 4? Yes, that'll be 2 and 2. Okay, so I have all of my numbers that I didn't break down anymore. That's what I'm going to be looking at. So I have all of these numbers are the numbers I couldn't break down anymore, right? I'm going to circle. I like to circle all of them. And now what we do is in that group of numbers we didn't break down anymore, we look for twins, okay? Twins. So right away right here, I have twin 2s right next to each other. That's nice, right? So what I always say is if you have a twin, you get to go outside and play. If you're a loner, you have to stay in the house. And the house is like the radical, okay? So these twins right here are going to go outside and play. Now the thing is though is that while they go outside, they combine into just 1 2. So now we have a 2 on the outside. The I is still on the outside. We have the radical. We don't know what's inside the radical just yet, okay? Now, I actually have another set of twins, okay? I have twin 2s here and here. They're not from the same branch, but that's actually okay. As long as they're in that list of numbers that I didn't break down anymore, then I can take them outside, okay? All right, so we have another set of 2s going outside. Whenever you have multiple twins going outside, the results are going to multiply. So an outside now I got 2 times 2. The I is still outside. Remember when that second set of twin 2s went outside, they combined as 1 when they're outside, okay? So then what's left inside is all the loners multiplied together. Now in this case, I only have 1 loner, and it is 5. All right, so what do I have here for my final answer? I have 4i times the square root of 5 would be my final answer there, okay? Now I wanted to show you guys, I actually wanted to go back now and do number 1 again, even though we already got the right answer. Because what if you would have missed that 36 was a perfect square? Could I have done the breakdown thing on this one? The answer is actually yes. So what if I would have thought, hey, 36, what if I would have said, okay, that's 12 times 3? Would that have been okay? Well, let's see what happens. I would break down the 12 as 3 times 4, and I would break that down as 2 and 2. And look what would have happened here. I got twin of all the numbers that I couldn't break down. I have twin 3s and twin 2s. So the 3s would have gone outside as a 3. The 2s would have gone outside as a 2. I already had the I there. And then there's no numbers, no loners to go in the house. And so if there's no loners to go in the house, you don't build a house. And so I would have gotten 6i. So I would have gotten that same answer either way, even if I missed the fact that it was a perfect square. Okay? On this chart, like the 4 and the 12 are not loners. To be a loner, you have to be one of the numbers that couldn't break down anymore. So if you broke down more, you don't consider that in the process, okay? Awesome. All right. So let's go on to number 3 here. So we got the square root of negative 100. So once again, first step is to take the I out front and then change it into a positive number. The square root of 100, I think we should know. That one's 10. Once again, though, if we did break, I'm not going to do it this time, but if I did break that down and look for twins, I would have ended up with the same answer if I did that right. All right, next up, number 4. First step, always the same for these ones. When we have the negative inside, is take the negative out, or get rid of the negative and put an I out front. And now we're going to break down 72. Do we know what multiplies to make 72? 8 and 9 is what I would have thought of as well. Whatever order you want there. There are other ways to get that. Like I think you could do 36 and 2. I can't think of any other good ones. 6 and 12, I think. But 9 and 8 is probably the best. Okay, cool. So now we'll break this down is 3 and 3. 8 is 2 and 4. And then 2 is 2 and 2. So we grab all the numbers that didn't break down, which are these. I look for twins, okay? ¿Cómo se dice? Necesitamos encontrar los gemelos, correct? Gemelos? All right, got it. All right, so we clearly have twin threes here. So the threes are going to go outside. Now I have triplet twos. I don't want triplets. I want twins. So if you have triplets, you don't have triplets. What you have is one set of twins and one loner, okay? And it doesn't really matter which one you call the twins and which one you call the loner, but so the twins, remember, they go outside, but they combine. And then we have another loner two that's going to stay in the house. Y por eso nuestra respuesta final es 6 y por el raíz cuadrado de 2. In English, that would be 6i times the square root of 2. So if I would have just had square root of 72, that would have been 6 rad 2. So now it's the square root of negative 72. It's just 6i rad 2. So very, very similar. You guys remember doing this a little bit in geometry and in Algebra 1 as well? They do it a lot, okay? So now, except they don't do it with the negatives and with the i's. Now we add the new thing this year, which is the i's. Okay, you guys want to? I feel like you're ready to try number 5 and 6 on your own. Okay, so I'm gonna pause for a minute here. I'll go ahead and I'm gonna take attendance actually. So you guys go ahead and try 5 and 6. We will go over them in about 4 minutes, but I want you guys to try it on your own, and then you get that satisfaction of doing it correctly when we go over it. Okay, so ready, go. First step, take the I out front. We'll call it rad 18. All right, we'll break down the 18. I would do it as 9 and 2. You could also do 6 and 3, but the 9 breaks down to 3 and 3. So on all the numbers we couldn't break down, we got twin 3s, and we have a loner 2. So 3i radical 2 for number 18. Once again, if it was square root of 18, that would be 3 rad 2. So now it's just 3i rad 2, okay? Okay, last up, square root of negative 54. This is actually Mr. Berry's football number. So that'll be on the quiz. No, just kidding. No, actually my football number was positive 54, not negative 54. They don't let you be negative numbers in sports for your jersey. Why is that? That's like half of the numbers, right? I want to do that. Oh, how about a negative decimal? I'm going to be like negative 1.5. That would be my jersey number. They should let you do that. All right, cool. You guys think I'm crazy, huh? All right, cool. I was kind of joking, maybe. Or they could let you be pi. That's a number. My jersey number, I'm number pi. All right, so we'll break down number 54 here. 54 is, I like 9 and 6 there. Did anybody have a different way to do 54? What was it? 27 and 2, that works. Yeah, you end up in the same spot either way. I guess you could have done, what can you do? 18 and 3, I think you can do. Okay. All right, so then we'll break this down as 3 and 3, and then this one down is 2 and 3. So it looks like I have twin 3's up here, and then I'm going to have a loner 2 and a loner 3. So the twin 3's will go out front, combine together. Now when we have two loners in here, they multiply back together when they go back in there. And so my answer here is going to be 3i radical 6. Sound good? All right, that's not too bad, right? Great. Okay, so let's move on. This next part I think will be even easier. There are two parts to each question. So part A says, identify the real and imaginary parts of the complex number, okay? So for number 7, the real part is 3. The imaginary part is negative 5i. So the negative piece is the piece that has the I attached to it. Remember, I kind of stands for imaginary. But you have to take the number with it and whether it's positive or negative. So the real part is 3, the imaginary part is negative 5i, okay? Next up, what's the conjugate of 3 minus 5i? Now, we kind of talked about this yesterday. Remember when we were dealing with those i's in the denominator, correct? So what I told you for the conjugate is, for the conjugate, you keep the real part the same, keep it real, but you switch the imaginary part. So for 3 minus 5i, it's going to be 3 plus 5i, okay? That's just the definition of the conjugate. We saw why we use it yesterday, so that we can get rid of these i's in the denominator. We don't like the i's in the denominator. But that is it. 3 plus 5i, okay? Remember yesterday I also did show you that Drake meme, or I'll pull it up again because the Drake meme is crucial to understanding of imaginary numbers. If I can find it here. There it is. All right, let's review the Drake meme. All these imaginary conjugates, and you still can't be real. So look what Drake did. He had negative 4 plus 4i on bottom. So he used the conjugate, negative 4 minus 4i, okay? So be like Drake, use a conjugate. All right. All right, so let's get back to our notes then. All right, so then number 8 here, we know that the real part is 6, and the imaginary part is a positive 3i this time, so I'll just put 3i. And then for the conjugate, remember we keep the real part the same, and then switch the imaginary part to the opposite sign. So in this case, we're going to switch to negative 3i. All right, the next two are a little bit tougher, but not too bad. For number 9, I think most of us can see that the imaginary part is 4i. Some of us may be wondering what I'm going to write down for the real part. Any guesses as to what's the real part of this? 0 is correct. There is no real part. It's all imaginary. But good thing is we have a number that means nothing. That number is 0. For the conjugate of this one, well, remember I said kind of keep the real part the same, but switch the imaginary part, correct? So in my mind, this conjugate would be negative 4i. I guess you could write 0 minus 4i if you wanted to, but 0, you don't need it, right? So I would just write negative 4i. All right, and then number 10, para empezar, el número realidad es 4 negativo. The real number is negative 4. El número imaginario, right? Imaginario, perdóname. The imaginary part is negative 5i. All right, the conjugate for this one is often, people often make a mistake on this one. The real part is going to stay as negative 4. A lot of people switch that to positive 4. Don't do that, okay? Remember I said, keep whatever the real number was, keep it the same. The only number you switch is the imaginary piece, or you switch the piece in the middle. So that's going to be negative 4 plus I. Okay, next up here, and lastly for our notes, and we'll be done for the day. Good job today for all of you who are taking notes. We're simplifying these large powers of I. So we've talked about for I to the first is square root of negative 1. We've talked about I squared is negative 1, correct? So now we can do with those two pieces of information, we can actually do every single power of I that there is, and I will teach you how, okay? So how do we do this? Well, I put it here in the notes. So it says even powers, you rewrite them as I squared to the power of n. I'm actually going to modify that right now, and I'd like you to do this with me. I'm going to call this over here n over 2, n divided by 2. Should I just put divided by 2? Sorry, it means the same thing. So if you already put over 2, that's fine. I'm just going to put divided by 2. And that's actually going to be the same for the odd powers as well. That's going to help us because we know that I squared is negative 1. And then I have two key facts here, okay? And this is going to be important for us to know. Negative 1 to any odd power is still negative 1. So negative 1 to the third power stays as negative 1. Negative 1 to the fifth power stays as negative 1. Negative 1 to the 69th power stays as negative 1, okay? Negative 1 to any even power is positive 1. So negative 1 squared is positive 1. Negative 1 to the fourth power is positive 1. Negative 1 to the 10th power is positive 1. Negative 1 to the 420th power is positive 1, okay? All right, cool. So let me show you how I do these. So number 11 here is an even power, correct? I to the 32nd, that's an even power. So I'm going to write it like I set up here. So I'm going to write an I squared inside of parentheses. Then on the outside of the parentheses, I'm going to take my power and divide it by 2. So 32 divided by 2 is 16. Are you allowed to use a calculator for that? Yes. All right, what's I squared? Well, we said that I squared is negative 1, correct? So I'm going to change that into negative 1 to the 16th power. Well, what is negative 1 to the 16th power? We have to go back to that fact I circled in right up there. Positive 1. Negative 1 to any even power is going to be positive 1. I said that our answers for these are always going to be one of these four things. I, negative I, 1, or negative 1. Did we get one of those four answers? Yes. Does this make it easy to make multiple choice questions on these because there's 4 possible answers for it? Yes, it does. All right, let's try this now with an odd power. So for an odd power, there's one extra step because you can see for the odd power, I have this I out front. So I'm kind of separating one I out here, and then I'm going to make this I to the 70th. So when you move that one I off to the side, your power decreases by 1. That's logical, correct? Now, I'm going to leave this I out front, and I'm going to change this to I squared to the power of 35. Why is that 35? Well, just like we did on the previous one, at that point where we break it up like that, we cut it in half. Okay, what next? Well, we know that I squared is -1, so I'm going to leave the I out front, but I'm going to change I squared to -1. So now we have I times -1 to the power of 35. What is -1 to the power of 35? Well, I said -1 to any odd power stays as -1, correct? Okay, well, I'm not really to one of these 4 answers yet, but I think I have just one more step. What do you think is I times -1? Well, what's 5 times -1? That's -5, right? 10 times -1, -10. So what's I times -1? -I. Is that one of those 4 answers? You're gosh darn right it is. All right, 2 more here. You guys are doing great. Keep it up. Almost done. All right, number 13, another odd one. So remember, first step for odd ones is to move one of your I's off to the side, which decreases it by 1, which makes it now an even number. Next step, take that even number, put parentheses with the I squared on the inside, and for your exponent on the outside, we cut it in half. So in this case, it'd be 22. All right, next up, we know that I squared is -1, so I'm going to change it to that. Next up, -1 to an even power. What's -1 to an even power? +1, very good. 1 times I, well, 5 times 1 is 5, 10 times 1 is 10, so I times 1 must just be I. Nice. Okay, one more. This one's an even one, so the even ones are a little bit easier. It's one less step. So we're going to start off here. We don't need to take that I off to the side for even ones. We just jump right into the I squared on the inside. And let's think about what that number would be on the outside if you want to write it down now. I got 33. Half of 66. All right. So we know that I squared is -1. So now we have -1 to the power of 33. And what is -1 to any odd power? Todavía -1 for the odd powers. So there we go. We got one of each of those 4 possible answers, okay? All right. Cool. So we finished with a little time to spare, so that's good news. So I'm going to say let's submit our notes by tomorrow. If you do it by tomorrow, that's fine. Make sure you save it as if you're doing it on your computer, so you can do that. And yeah, tomorrow we'll do our puzzle piece. Okay, that sounds good. So save your notes on your computer as well, so you can look at them tomorrow when you're doing your puzzle piece. Sounds